This is my SAR ADC clock circuit. This video will explain how the clock works and a general overview of the SAR ADC. The reason it does not appear to oscillate is because the frequency is 103 microseconds, far too fast for our eyes to pick up. Here's how the circuit is built. Let's start the circuit with just two inverters in series with two capacitors connecting each input to the other's output. Simply, when one output is high, let's call this N1, the other will be low. Then, two resistors are added, connecting each input to its own output. This is the result, an astable multivibrator. Initially, N1's output will be high, allowing voltage to flow through R1 and ultimately to this capacitor. Over time, this capacitor will charge up, causing voltage across that wire to increase. Once the voltage reaches a certain threshold, it will trigger the inverter, flipping its output to low. In full stat, this measured value was 2/3 of the source voltage. Once N1's output is low, N2 will go high. The same process will occur, and as this capacitor charges, voltage will increase. Once it reaches that 2/3 threshold, the gate will trigger and it will flip again, repeating this process to the start. Here's another way to lay out this clock to show its symmetry. Technically, there are two places that produce a square wave output. However, they will be in opposite phase to another. Here's the output frequency from N2 on an oscilloscope. On the other hand, the inputs of both inverters create a half-charged oscillation, opposite phase to each other, and here's N2's input shown on the oscilloscope. Here's the schematic for the SAR ADC, where the clock is in the top left corner. Here is a block diagram for this circuit. The SAR ADC is a type of analog to digital converter that constantly feeds back on itself until it reaches the correct voltage. First, an initial sample of the analog voltage input is stored in this sample and hold IC. The approach to finding an accurate voltage is based on a binary tree. So on the other side of the comparator is a DAC R2R ladder, which creates these half inputs of a binary tree. To start, it will compare the analog input with half of a maximum reference voltage. And let's say the reference voltage is 5 and our input is 1.5 volts. So in a 3-step SAR, for simplicity instead of 8, here's the process. First, it will compare the 1.5 volts with half of 5 volts. Since it is less than 2.5 volts, it will take this path, where it then compares half between 0 and 2.5. Since it is greater, it will then compare half between 1.25 and 2.5. So in only a 3-step process, our final output would be 1.5625 volts. So as you could imagine, an 8-step SAR would give an extremely accurate result.